right, good morning, also possibly good afternoon, mathematicians, depending on when you guys are watching this video. But anyway, in this video, I will be walking through Primetime Investigation 3.1 and 3.2. This is found on page 19 in your packets. Okay, so we're continuing the learning. Even though I'm not here, I made this video, guys, for you guys, to make sure you guys get a good head start on this concept, okay? And we're going to be talking about this thing called factorization. As you can see in our focus question, we're focusing on a specific type of factorization called prime factorization. Whoops, let me change that. Prime factorization. So our focus question is, how can you find the prime factorization of a number? And you're probably wondering, Mr. RG, I have no idea what that really long phrase means. Well, we're going to talk about it so that you know what it means, okay? But there are some other vocabulary words that we should know before we dive into today's lesson. Okay, now the first word is called exponent, okay, and it is the small raised number that tells how many times a factor is used, okay? So you guys have seen, I refer to them as small floating numbers in our previous lessons. So you guys have seen things like this, right, with a floating 2, and I read this as 2 to the power of 2, or I say 2 squared, which we've been saying in our covering and surrounding unit, right? When we're talking about area, our units are always squared, okay? So in this case, this floating 2 is telling me, well, how many 2's am I multiplying here, right? So I translate this 2 to the second power, or 2 squared, to a multiplication sentence like this, 2 times 2. Okay, I want to show you another example. I'll use 2's again. Let me change colors here. I'm going to say 2 to the third power. And again, we are looking at that small raised number. Now, hopefully you guys remember what something raised to the third power is. Some of you guys might remember that we call it cubed, right? So 2 cubed, or 2 to the third power. If we expand it, it looks like this. We do 2 times 2 times 2. Now, a pattern you guys might notice is, well, depending on what the exponent is, right, that's how many numbers you're going to be multiplying here. And in this case, we're multiplying 2 3 times. And then in the first case here with my exponent of 2, I multiply 2 2 times. Now let's look at one final example here. Let's do 4 to the fourth power. Okay, now if I were there, I'd ask you guys, well, what numbers am I multiplying and how many of them? That's what I would ask you guys. But because I can't, I'm not there today, hopefully you guys are thinking about, well, I know that this number 4 is going to be multiplied 4 times. So I'm going to write 4 times 4 times 4 times 4. Okay, so that's how you expand these exponents, okay? And we're going to use them today in this crazy thing called prime factorization, but we'll get there in a second, okay? So that's how exponents work. Next, we're going to look at this thing called factorization. So this is a product of numbers, perhaps with some repetitions, resulting in the desired number. So let's take one of my favorite numbers, 24. It appeared in a lot of my previous notes. 24. I can write that as, here, let's do 1 times 24. We know this is equal to 24, right? This right here, this multiplication problem that I just did, that's what we call a factorization. But I can write multiple factorizations here. I can change it to something like this. I can do 1 times 8 times 3. And do I still get 24? Yes, I do. I can rewrite it again. I could do something like this. 1 times 4 times 2 times 3. Do I still get 24? Yes, I do. And there I have another factorization. I can do even more. I could do something like this. 1 times 2 times 2 times 2 times 3. Does that equal 24? Well, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times, yes, it does. So all of these right here are what we call factorizations, right? We are breaking down this number 24 into a multiplication sentence, into its factors, okay? And this is going to help us understand what prime factorization is, because I can consider all of these examples that I just wrote as factorizations, okay? But there's something special about prime factorization, and I think some of you guys might have an inclination, or you might have an inkling as to what that means, okay? But right here, I'm going to highlight it. It's a product of prime numbers, okay? Now, I want you to take a look at the examples that we wrote. Here, I'll highlight them. These examples here, which one of these looks like a product of prime numbers? In other words, which multiplication sentence has only prime numbers? And you might say, hopefully you notice that this very, very last one, if you take a look at the factors, I'm going to rewrite it here. 1 times 2 times 2 times 2 times 3. And this is equal to 24. If you take a look at the factors of 24, the way we wrote it here, if you take a look at the factors, what do you notice? Well, all the factors are prime. This is what we call prime factorization, and that's what we're going to be practicing today. Okay? So yes, it is okay to have some repetitions in there. I mean, look, I have 3 2's in there, so that's okay. The only thing that matters is that all of the factors are prime. Okay, so let's get into it. What we give you guys here, this right here, these are all of your divisibility rules, right? So how do you know if a number is divisible by 1, by 2, by 3? It even covers 4 and 7, which are a little complicated, but you know, you guys can take a look at those later. But we've talked about 2, we've talked about 3, we've talked about 5, we talked about 6, we talked about 9, and we also talked about 10, right? I mean, also technically 1 as well, okay? We talked about those ones. So those are the ones that you really, really need to remember. The other ones, not so much, but it could help you a little later, okay? So here's what we're going to do. We give you guys the process of how to find the prime factorization of a number. In this example, it's 84, okay? So what I'm going to do is we're going to start on page 19, and I'm going to be going back and forth between this step-by-step guide right here. So this is our step-by-step guide to prime factorization. So you guys can write that down if you want. This is how to prime factorize something. We'll call it prime factorization, okay? So I'm going to be going back and forth between this because I feel like this is just a lot of words, and it's kind of hard to understand at first. But once you kind of do it and you see what's happening, then it's a little easier, okay? All right, so let's take a look at the number 32. Now, if I go back to step 1 in my prime factorization to-do list, it says, write the number to be prime factored at the top and draw 2 branches below it. So we have the number 32, and we're going to draw some branches below it. Well, just 2 of them. Okay, we're going to split this. Now it says, list item number 2, write its smallest prime factor on the left and circle it. If the number is even, this will be 2. Write the companion factor on the right. Okay. So let's take a look. Is 32 even? Yes, it is. So 2 is the smallest prime number that goes into it. And we're going to put a circle around it. Okay. Now I need to ask myself, well, 2 times what gives me 32? So if you're thinking, well, 32 divided by 2, that gives me 16. And there we go. Okay, back to my to-do list. I'm on step number 3. If the companion factor is composite, draw 2 branches below it and repeat step 2 for this factor. Okay, so if the companion factor is composite, Well, I need to ask myself, is 16 composite? Yes, it is. There are multiple factors that go into it other than 1 and itself. Okay, so I'm going to repeat step 2. Now, 16 I know is even, so I know the smallest prime number that goes into 16 is 2. So there we go. There's 2. And then 2 times what gives me 16? Well, I know that 16 divided by 2 gives me 8. Now, going back up to my to-do list, it says in step 4, continue repeating steps 2 and 3 until the companion factor on the right is prime. Circle that prime number also. Okay, so let's keep going. 8 is composite. 8 is even, so therefore, I'm going to draw 2 branches again. 2 is the smallest prime number that goes into 8. And then 2 times 4 gives me 8. Okay, is 4 composite? Yes, it is. It is also even, so I'm going to keep drawing my branches here. So 2 goes into 4, and then 2 times 2 is 4. And remember, 2 is a prime number, so we're also going to circle it. Now, going back to my to-do list, number 5 says the prime factorization is the factors on the left and bottom of the tree that are circled. So I'm going to highlight them here. So all of the numbers that are circled become your prime factorization. So it kind of creates that little like slanted L or a backwards check mark. So I'm going to write the prime factorization like this. 2 times 2 times 2 times 2. I have 4 2's, I have 5 2's. There we go. Now the directions say write the prime factorization of the number, but then it says write the answer using exponents. So remember, going back to that definition of an exponents, we need to change this 2 times 2 times 2 times 2 times 2 into something with exponents. So I need you to ask yourself, how many 2's do you see? How many 2's are you multiplying, I should say? Well, hopefully you said 5. So we're going to change this into 2 to the 5th power. And that is your final answer. Okay, let's try it again. I'm going to walk you guys through probably 4 of these, okay? And then I expect you guys to be able to pause the video and try it on your own or in your groups. And then you'll be able to check back with the video, okay? So let's go through number 11 together. I'll switch colors. So what's nice is that every even number that you start out with, you know that 2 is going to be the smallest prime number that goes into it. Okay, so we circle each prime factor. So don't forget to circle the prime factors, okay? All right, so 2 is a prime factor. 2 times what gives me 42? Well, let's double check this because I don't have a calculator. That goes in 2 times. So 21 is my answer here. Now, remember, is 21 composite? Does it have factors other than 1 and itself? Yes, it does. So I'm going to draw 2 branches. Now remember, the branch on the left is going to be the smallest prime number that goes into 21. Okay, so I would start from 1. Well, obviously 1 goes into 21, but we don't want to write 1 because then we're going to get the same type of problem. So let's try another number. Can 2 go into 21 evenly? No, it can't. 21's not even. Can 3 go into 21? Yes, it can. So I'm going to say 3 is the smallest prime number. I'm going to circle it. And then 3 times 7 is what? I mean, sorry, I just gave you the answer. And then 3 times what gives you 21 is what I was supposed to say. And 3 times 7 is 21. Now I need you to ask yourself, is 7 a composite number? If you say no, you're going to circle it. Now, we need to write the prime factorization of the number, so we're going to write a multiplication sentence with these 3 numbers. So 2 times 3 times 7. And this is your final answer. That is the prime factorization of 42. And there we go. Okay, let's keep going. Let's try another one. 54. So is 54 even? Yes, it is. So therefore, the smallest prime factor is 2. Now 2 times what gives you 54? Well, let's check it. That goes in, 2 times. So that's 4. 2 goes into 14, 7 times. There we go. And then the companion factor there is 27. Is 27 prime or composite? Hopefully you said composite, because I can definitely split this into 2 factors there. So the smallest prime factor that goes into 27. Well, I know 1 goes in, but that's not going to help me. 2. 2 does not go into 27. Does 3 go into 27? Yes, indeed it does. So we're going to circle it. And then 3 times what gives you 27? Well, 3 times 9 is 27. Now you're going to ask yourself again, is 9 prime or composite? Hopefully you said composite. And we do 3 times 3. And we know that 3's are prime. So therefore we're going to circle. So I want to point out to you guys, once you have these 2 numbers at the bottom of your tree circled, that means you're finished. That means you're done with the prime factorization. And we can write our multiplication sentence now. So it looks like I'm multiplying 2 times 3 times 3 times 3. Can I use exponents here? Do I have a number that's repeated a certain amount of times? Well, if you take a look, these 3 3's, I can definitely rewrite as an exponent. So here, I'll move down here. There we go. So I can rewrite it as 2 times 3 to the what power? Well, how many 3's do I have? I have 1, 2, 3. So 3 to the 3rd power. And that is my prime factorization. So 2 times 3 to the 3rd power. And boom, we are done. Okay, let's do one more together, you guys. Let's go in green. Okay, so starting out, is your number even? 48 is even, it ends in an even number. So therefore the smallest prime factor that goes in is 2. Now you need to ask yourself, 2 times what gives you 48? Well, 2 times 24 gives you 48. Okay, I know 24 is composite, so it's going to have 2 branches. The smallest prime number that goes into 24, because it's even, is 2. So there we go. And then we know that 2 times 12 gives me 24. I know 12 is composite, so I'm going to split this into 2 branches again. 12 is also even, so therefore the smallest prime number that goes into it is 2. And then 2 times 6 gives me 12. Now I know 6 is composite. There we go. And 6 is also even. So therefore 2 is my smallest prime number. And then 2 times 3 is 6. And I know that 3 is also prime. So now I'm going to highlight my prime factors, 2, 2, 2, 2, and 3. And I'm going to write my multiplication sentence. So I have 2 times 2 times 2 times 2 times 3. Okay? Now remember, the directions say to write the answer using exponents. Can I use exponents here? Is there a number that's repeating a certain number of times? You might say, yes, this 2 is repeating 4 times. So how do I rewrite that as an exponent? Well, you're going to take the number 2 and you're going to raise it to the 4th power. And then we're just going to bring the times 3 down here. So we have 2 to the 4th power times 3. And that is your final answer. Okay, so now that you guys kind of have an idea of how to do this, you're going to try it on your own or in your groups. Okay, so if you get stuck, remember you can always go back to the examples that I worked out for you. Okay, in case you forget your steps, or you can always refer back to our prime factorization checklist right here that I'm boxing in green. Okay, if you follow those directions, you will be good to go. All right, so go ahead, pause the video, please, and try 14, 15, 16, 17, and 18, and then we'll continue the video. All right, mathematicians. So take a look at numbers 14 through 18. Okay, double check your work. Also, double check my work. If I made a mistake somewhere, please let me know. Either you can write it in the comments or you could tell me during class next time, okay? But more or less, here are the answers. All right, and then we have one more thing to talk about, where I give you the prime factorization of a number already, and you got to work backwards, and you have to tell me, well, what is the number? So I tell you that the prime factorization is 2 to the 4th power times 3 to the 2nd power times 5. Okay, now we need to make this make sense in our brain a little bit. So here, can I read this? Is that okay? I think so. All right, so I'm going to rewrite this. I'm going to expand these exponents. Okay, so 2 to the 4th power I know is this, 2 times 2 times 2 times 2. Okay, can you see? That's a little light, even for me, and I'm the one writing it. Here, let's move to a darker color. There we go. 2 times 2 times 2 times 2. Okay, so that's how we write 2 to the 4th. See if I can, I'll move that down a little bit, and then I'll label this. So this right here is the same as 2 to the 4th power. And we are multiplying that by 3 to the 2nd power. So that's 2 3's. So this right here is 3 to the 2nd power. And then the last number we're going to multiply by is 5. So if you have your calculators ready, you're going to do 2 times 2 times 2 times 2, which equals 16. Then you're going to multiply that by 3, and then by another 3. And so far we're at 144. Then you're going to multiply that by 5. So the final answer is 720. And there we go. Okay, now I want you to try the second one on your own. The prime factorization of a number is 2 squared times 3 squared times 7. What is the number? Go ahead, pause the video, try it on your own first. All right, hopefully you pause the video. So 2 squared is rewritten like this. So this is 2 squared. Then you're multiplying that by 3 squared, which is written like this. So this is 3 squared here. And then the last number we're multiplying by is 7. So 2 times 2 is 4, times 3 times another 3 is 36. And then 36 times 7 is 252. And there you go. Okay, so now you guys can go ahead, summarize your learning from today's lesson. Write 3 sentences describing what we did here, what the process was like, okay? And then you guys can go ahead and try your homework. Okay, so once you're done with the video, it's much shorter than my other ones, so you guys will have time to work on this. And if you finish this, then if you finish page 21, then you have no homework today. However, if you do not finish page 21, then that will become your homework today. So it's up to you whether or not you have homework tonight. Okay, so if you guys are confused, please come see me during RAM. I will be happy to help you there. Okay. All right, you guys. Well, good luck today, and